MBA now.
You're getting an MBA?
I'm getting MS.
You're getting a Master's in Science?
Yeah.
Okay. You, Cliff, what do you get?
I've already have an MBA.
Oh, I'm sure you've got multiple.
This is like my 8th or 9th graduate degree.
Oh.
Okay, you gotta enlighten me. What are you doing it for?
Keep my brain working.
I mean, doesn't the other 7 keep your brain working?
No, I'm a professional student. There were always professional students up at UConn. I always loved that idea. Just keep on taking classes.
So why not go for your doctorate and become a teacher?
I already have a doctorate.
Wow.
So then why not teach?
Because the deal wasn't that great. I told the other guys. This was back in 2000, late 2000s. The engineering professor's contract was $95,000 a year to start. They gave you 2 graduate assistants, and all you're doing up there as an engineering faculty is writing grants for 50 hours a week, because you have to support yourself, any grad students you hire, and the school takes 52% overhead off any grant that you get. That's how the schools make money.
Interesting. And you've got to do all your grant writing on your own. and
Yep,
all of
that's all they do. They teach 3 courses a year and they do grant writing. That's all they do.
Wow.
That's all faculty at the research. It's different for the business because they don't have all this research. They only have, in finance, they carry 4 PhD students. But they'll use them primarily for teaching undergraduates. That's what they'll do besides their own research.
How long would it take for you to reach tenure? I've always been.
You got to do it at 5. You're considered tenure track eligible in 5 years,
5
which means you had to be cash flow positive within that first 5 years. Otherwise, they drop you from the tenure track.
Got it. And then you're just adjunct.
No, you could still stay on as an associate or assistant professor, but you wouldn't be on the tenure track anymore unless you had a big change in your performance abilities. Like, I know one guy who didn't get offered tenure. He wasn't tenure track after 5. He was a smart guy, but he just kept at it, and they eventually changed their minds and put him on tenure track. But a lot of guys will leave and go to some other place once they think you're off the tenure track. Go try it somewhere else. A lot of the good engineering faculty won't stay at UConn because there's better opportunities elsewhere.
What, they would go like MIT or something like that, or?
Well, the biomedical engineering guy, biochemical engineering, he did a lot of gene research with E. coli, and I worked for him for a summer. He actually had about 20 graduate students work for him. They actually published 40 papers a year.
Jesus.
And he eventually went down to Texas A&M, and about another 4 or 5 years later, he went to Penn State. I don't know if he's still at Penn State anymore or not. He's probably retired. He was a little older than I was at the time. So the schools want that publication stuff.
Well, to bolster their pedigree?
Yeah, it looks good for them to do research. That's all engineering is about, is doing research. And what sealed the deal for me was I developed this new kind of bioreactor that UConn eventually patented. And that was my claim to fame. That UConn may produce about, between graduate students, MDs, JDs, maybe about 1,000 to 2,000 doctorates a year. They only get about 25 patents a year.
And you got one.
Yeah.
Congrats. Nice. I mean, are we clipping royalties off of that patent?
Well, the thing of it is UConn owns the patent when you do it in their labs.
Mm-hmm.
It's actually in the faculty contract and they made us sign a waiver that was technically 4 of us. So UConn takes 2/3 for themselves. And the 4 of us, the 2 faculty members, me and the undergraduate who was working with me, all 4 of us split that last third.
That last third.
Yeah. Theoretically, they will tell us if they ever sold it. I think they have, but haven't pushed it or anything, so I don't really care. It doesn't matter to me. It was doing it that was important for me.
Yeah, I need the money. I want the money. I got 2 kids to put through college.
See, well, I never did that stuff. I never did the married stuff. I never did the kid stuff.
Really?
So I just lived by myself.
No
So
wonder
I
you
need
can afford all
nothing.
these degrees.
I don't need anything else than a roof over my head and car, truck, motorcycle at different times.
I like that. My kids don't allow me to do any fun stuff in my money.
If you look at some of the Reddits, people are getting undergraduates from out of state are applying to UConn to go here when the total cost is like $63,000 a year for an out of state student.
Why?
That's a good question. Is why UConn is no place to be spending that kind of money to go to school for.
I know why. It's for the basketball. Come on. It's for the basketball.
They actually, when I was first year was an undergraduate back in the '80s, they weren't that good in basketball.
But that could be the only reason. Like they want to be considered
Yeah,
Huskies.
it's a great marketing tool for them.
100%. 100%.
And Calhoun came like about 2 years after I was there, and that's when they started to get good. But Dom Perno was the first coach, and he was a laughingstock. The kids always made fun of him. Look what Dom did.
My cousin was actually coached by Hurley back at St. Benedict's.
Hurley's good.
Say it again?
Hurley is good.
Yes. But he was a psycho still.
Oh, he still is.
The person that you see on television now, he was the same way in St. Benedict's, where he started.
That's why coaches like him stay in college, because they can get away with stuff that the pros would never tolerate it.
Never work in the pros. Like no matter how much passion you have, like you could just say it's passion, it'll never be received as passion in the NBA. Very few get away with that. Pat Riley's of the world, they get through that kind of stuff.
A little late.
How we doing, Mr. McDonald?
Doing great.
So just to confirm, and my young friend here is double confirming, this really is our last class.
Yep.
Yeah, that's it.
That stinks.
Just getting fun.
I just started kind of learning something. I don't know what to do after this. I'm just gonna go in blind. I'm gonna email you.
Keep going.
I'm gonna email you and Professor Hayes, continuously.
It's nice.
Well, take the summer course.
Say it again?
Take the summer course.
It's nice.
I might. Wait, I gotta make sure that it's an elective that'll count towards my degree.
It's on Monday nights.
Monday nights in the summer? Oh, forget that. Can't do that. That's prime baseball time for my son. I'm already missing a game right now.
I don't have too much. Professor Hayes will come and.
Professor Hayes, he said he'll be here around 7, so maybe we just wait for him. And he may be bringing, I don't know if he's bringing plates, but, you know.
We don't know, get too cold.
Just put it right on top of my,
Oh, yeah, laptop. Time for a new laptop.
oh no, not this one, I'll use my work one.
So this is, I mean, this will take up the time till Professor Hayes gets here. All right, so everybody, for the most part, everybody submitted the credit scoring assignment, so thank you very much.
I saw your feedback, thank you.
Yeah, and I sent people feedback this year, which was hopefully helpful.
He said mine completely sucked.
Oh, come on.
It was for shit, that's what he said,
No,
his words, not
I
mine.
would never say that. Never say that. Okay, so the first thing is, I think everybody did a really good job. Lots of times people struggle with, to do all the predictions. So the file we needed to predict was 37,500. Everybody got that, so you had to deal with things like missing data, and everybody kind of did that pretty well. 2 people submitted multiple models, so in the assessment, I included all the submissions just to see sort of like a better distribution. So
Wow.
really good. This data was taken from, I don't know if people are familiar with Kaggle. I think maybe Professor Hayes has talked about it, but it's like a data science contest website, right? So this one is kind of an older one from 2011. It's called Give Me Some Credit, I think was the name of that one. And so it was a good place for me to take data from. But it also meant that we have a sort of a benchmark, like a best in class. So like at that time, what they'll do is they'll put this data set out there and they'll give people some amount of time, month or 2, maybe 6 months, to come up with the best model, and then it's a contest, whoever submits the best model, right? So the class's top score was 8642, and that was within 99% of the original winner, which the winner, I think, got $5,000 back then, and that was 8695. So that's really good. I think that might be, I don't know, I don't keep track of former submissions, but that might be probably it might be the highest one I've ever seen, which is great. The thing is like that incremental from 8642 to 8695 could take a long time to get, because like every little last percentage point of performance is like that much harder to achieve. So, so you know, yeah, it's like, you know, the 80-20 rule, but like taken to the next level. Right? So you could spend a lot of time and effort to get from 8642 to 8695, but 8642 is great. And the top 5 students all scored above 84 AUC, which is very good. So the top 3 submissions were only 30 basis points of AUC far away. So for folks who did send in their code, XGBoost emerged as the clear winner. So people who used that one got very high scores. So, and then some people used R, some people used Python, so that's pretty good. So I'm a huge advocate of doing what feels comfortable, right? That's kind of why I stick with R, just because I learned it way back when, and I'm okay with it. I will say that, like, I don't know if anybody was using assistance from GPT or ChatGPT or what else is there? There's,
Claude.
Claude is great. Claude Code is great. Claude Work is really good, and then GitHub Copilot is very helpful as well. But it makes sort of the choice of language even less of a consideration, because it's all there in front of you. You have a near expert, and within 6 months it's going to be the world's greatest expert who's there to help you. So that's really good. So, you know, this is, I love this picture of sort of the trade-off that oftentimes happens between flexibility and interpretability. That's from the book. So it's unsurprising that the sort of the models such as XGBoost sort of fall into that high flexibility, meaning they're really, really good at describing data and learning from data, but maybe less good at sort of understanding what moving pieces are in there, right? So I would say they are on the low interpretability spectrum, but high flexibility. So they're really good at things like identifying or learning nonlinear relationships and these types of things. So it's unsurprising that, given the expressive power needed to capture complex nonlinear relationships. So the benchmarks we have here, remember this AUC metric, 50% is kind of the worst. It's a purely random model, right? So 50, and then, you know, I kind of fumbled on giving the example, but I sent it out afterwards. That sort of super simple age-only logistic model, but that achieved a 64 AUC. So we did much better than that. So I was very happy with folks. And if you did send in your code, I tried to send you back some feedback. So that was good. So this was the leaderboard. I did anonymize it, so I didn't want anybody feeling like they were called out. But this was sort of the distribution of scores in a table sort of way. A lot of people beat my submission, which was really good. Happy about that. And then this is the distribution of scores. So you can see that a lot of our scores, we had a nice representation out here above that 80%, the Kaggle winner being that 86.95. And folks down here improved on the baseline, which was really all we were looking for. Hopefully you might have learned something by doing the exercise. You know, for folks who did submit multiple models. One person submitted 6 models. We can kind of see here like
What?
the, well, this is not atypical. You would experiment with different models, see what works best. So it's and there are certain tools out there. I don't know if this student used tidy models, but some of that tooling is intended to build different models and compare them. So, but we can kind of see here, like, we get good performance, better performance from XGBoost, and then like Lasso being a very sort of interpretable model, but maybe less performative when it comes to scoring, getting a high score. So that's kind of my, so I put this document in a PDF form up on Husky CT, and it's also in the GitHub repo. And if you do want to sort of dig into it more, this is the link to the original score, the original competition. And you can see, if you're really interested, you can go there. It's kind of a cool website. They've got contests, and this will have a lot of information about other people's approaches to doing this. It might be a bit dated now because it is kind of from 2011. So.
Do they have different competitions? where you
Yeah,
can
they've got a
do-
ton of different competitions, and they're always coming out with new ones. I never really got too into it, but I know that people who did, and they
And
became
so-
really good at modeling.
So with this guy, let's say I wanted to go experiment and do a model that they, give a competition about. How could I grade myself based on what I come up with?
Oh, so the way
Like
it
you
works.
see how they have the Kaggle winner, do they post that, or did you just have?
Yeah, no. So they'll have it so that you can make a submission, and I think they'll give you feedback on your score, or they'll wait till a certain date and then they'll sort of, but you don't have the answer key.
Got it.
So, and then they do, like, I use it, cause I do, like an NCAA tournament model. And they've
For
got
March
they've
Madness?
got a Kaggle competition for that, where they have just all the data. It's really helpful. So I go there for that, but I never submit my model. I use it to lose money with my pools at work. Yeah,
Oh,
that's
do
what I
you're the one that goes and tries to do the perfect bracket for Warren Buffett?
Yeah, it's never happened.
Never.
Okay, and I did put my code out there, but once again, I think judging from the scores here and how a lot of people beat me, it might not be the most useful thing. So, that's all I got for tonight. So now we're just waiting for Professor Hayes to get here. Hopefully he'll have some drinks and maybe some, if we have a plate, that'd be nice too. We don't have plates and napkins. Did you have a question?
Well, I was gonna ask, so I know a couple of people in here suggested probably a more rudimentary version of this class that could teach you like more of the basic stuff.
Yeah.
In the event that's not an option, for R and for Python, I asked Professor Hayes the same thing. Where are those places to go
Yeah.
to like learn the
Learn
syntax,
stuff.
the nascent like, okay, hold my hand and do this.
Yeah.
I don't wanna be the lazy guy and just say, Claude,
Yeah.
teach me, or you do it for me.
Yeah. It's because it's too tempting for me.
Yeah.
I mean, I can't speak to Python. Maybe Professor Hayes has a.
Yeah, he's given a
answer
couple
there.
options.
I mean, I always think that Posit, which is formerly RStudio, is sort of a great resource for a lot of things. So they're the ones who have all of those cheat sheets. But like, if you go to just resources here, right, you can, well, there's all kinds of stuff, support knowledge base. I mean, so, I would even Google like getting started with R, or however sort of far you want to go.
There are classes here in the economics department for R and for Python.
Yeah. I haven't really I don't know much about those, but I'm
I
sure
took
that,
the
I'm sure that
Python
there's
one.
a class that's like intro to R.
Will they count towards my degrees?
For an MBA?
I'm pretty sure they're all undergrad level classes.
No, the graduate. The economics is a lot of combined they'll give you a graduate course level, and the undergraduate students take the same course, and maybe they don't do as much work, but
How about I just pay you and you teach me?
we already had this discussion. I'm not looking for money.
Hey, my grants, I won't pay as much. The grants that I can give, they're not as lucrative.
My goal is just to not pay taxes. That's all I need. If I start paying taxes, I'm making too much money.
It's never what you make, it's always what you keep. That's the philosophy. Also, tax avoidance is not bad, tax evasion is. So as long as you're avoiding taxes, you're good to go.
Yeah, so there's a lot of, I don't have like, I think that's my finger, like I'm
How did
probably,
you learn?
I mean, I learned by doing, so like I had to do stuff on the job, and I do it.
No, but I mean like, okay, when you started your career,
Yeah.
and I don't know where you started, was it with Linux or like, before R existed?
Well, before R was S.
Yeah, before I was,
Before-
yeah, but
Before that was
so-
Fortran.
I mean, yeah, I got my intro to like coding through more like Microsoft stuff, so like I was doing, I mean, it's still Excel, and then back then there was like they still have it, but I don't think people use it as much, Microsoft Access.
Oh, I remember, that's a
Yeah.
database, yeah, that's
that's,
still.
that sort of desktop database thing, so we were using that heavily at my first job. I was an actuary at the time. And then.
That is
I-
the craziest job, just
Yeah.
looking at data like that.
Yeah, it was I was a math major, so it was kind of.
Oh, so it's riveting to you.
It was kind of a clear path. And then, I got more involved with like the VBA stuff. And then, back then, you could pretty much get a job if you said you knew HTML. It's a bit of a different thing these days.
Gotcha.
And then when I got involved with R, I was working at IBM, and I was working with a guy from the research center who introduced me to it. But back then, there was no like IDE for it, so you basically had a terminal, you were typing commands in, and then a text document off to the side, you were pasting back and forth.
And you learned R from just doing blunt force trauma, just playing with it.
Yeah,
Wow.
yeah. And then I kind of stuck with it. Now we write packages at my job, so primarily for us to use, but we're kind of we're not really distributing them out to many other teams.
That's what because I was talking to Cliff about that earlier, and I was trying, like, let's say you create a code here.
At
that is-
UConn?
Yeah, that's revolutionary, that does something, like, you make a credit model that can, within a percentage point, predict, whether I don't know, somebody's like Moody's, like a company is they're about to go insolvent, and you can change their credit score. You can see it in advance.
Yeah.
And I mean, predicting the future or being a predictive model, you can make a ton of money off of that. Do you get that?
So, no, my deal with my company is like they kind of have my intellectual property of anything that I would build. There. So like, even if I could, I mean, if it was that, I don't know, I'm not having that great of an idea. But even if I did, it would be kind of like, even if I knew the code and I had it in my brain and I just left and recoded it somewhere else, they probably would sue my hands off.
So if you built it at your house on your own terminal, they can't get that. That's yours.
Yeah, that's mine. But I'm sure that like, yeah, they'd notice if I was, the next Elon Musk.
Well, I'm pretty sure that they would find a way to
Yeah.
say he learned that piece of code on our premises and he
Yeah.
bootstrapped it.
I mean, a lot of the stuff I would do, I probably would make open source, right? So I've never published an open source package. Professor Hayden said he will be here at 7:05, but he needs someone to help him carry the drinks in. So I'll go. Does anybody want to come?
I would. I've only got one foot.
What's going on?
Dropped a weight on it and tried to play baseball with it,
Oh, man.
and
Doing too much. All right, let's go. We'll be right back. Oh, jeez, kind of stuff.
be honest. Who got the 8-6? Who did it? It was you, wasn't it?
No, it wasn't me.
Don't lie.
No, it wasn't. Trust me.
It was you.
No, not me.
It was you?
No.
Cliff. It was you. Good job. Congrats. See, but that's no fair. You're a ringer. That's not fair. You're a ringer. Yeah, mine was rudimentary. I only got 0.8. I'm nowhere near what these guys got. I thought 0.8 was good. I was like, okay, I'll take that. I should have sat with it for another day then and tinkered with it. Yeah, his feedback was nice, but it was almost like no shit. He said you could use more sophisticated code. I'm like, there's nothing sophisticated about the level of code that I can put together right now. But yes, I will try. Now I've got to figure out how to get to 8-6. Now it's gonna bother me. I ain't gonna have this guy beat me. I'm gonna figure it out. It sucks, but.
Yeah.
Like I said, ego will get you hurt when dealing with 10-year-olds.
Yeah.
So how does working for a small credit company work? Like, how do you compete with Standard & Poor's and Moody's and all these guys?
Well, a lot of it is that we kind of find niches that work. So like, the big break for my company, so we started in 2011 was our first rating. And it just coincided with, S&P felt the blow, that they were forbidden from rating, commercial mortgage-backed securities. So like, that was our big entry point, like
So
that
there was
kind
a-
of started the,
There was a gap in the market and you guys were able to.
yeah, we were like trying to start it up. And then we kind of built it up, mostly in like structured credit. So we do a lot of residential mortgages, commercial mortgages, asset-backed. And then, the new thing is, and you're hearing a lot of it, is we do a lot of private credit ratings. So
Interesting.
Yeah.
So you're rating,
we're rating like a fund. I think.
so you would rate like something that Apollo is trying to put out there, just as an
Yeah.
example.
Yeah.
Wait,
So why is private credit collapsing?
Well, some of that is,
Not really true?
not the most true, but like, I mean, it's a bit bubbly and frothy.
well, what do
in
you
fact.
mean that it's collapsing?
People are pulling all the funds out of it.
Yeah.
I mean, yeah, it's frothy because you know how much money has gone into private credit?
Yeah. But right now, it's like the software companies, like they have a lot of, they've got problems with some of their investment related software companies because are not faring well in the age of AI.
Investing in pure R&D is not always the best. Like,
Yeah.
like if you don't have a MVP, it's
I
tough
mean,
to.
the big one was Tricolor, was it a big in the news? That was a big splash in private credit because like, but it was fraud, right? So like somebody, what were they doing? They were like using the same collateral to get loans in a lot of different places.
So effectively, they were doing.
It was fraudulent, they were committing fraud, right? So like a credit rating, yeah, we're not a fraud rating, right? So like there is a susceptibility now, I mean,
That I don't think there's a business there. I mean, it sounds like there's a business there for a fraud rating, but I don't think anybody can subject themselves to a fraud rating.
yeah, nobody wants to fraud rating.
But I guess, so how did you become the standard that people go to? Because that's effectively what it is, I guess.
What we wanna do, actually. I mean, yeah, I mean, we're looking to, they call it the big three, I mean, you've got Moody's and S&P and Fitch right now.
Yes, Fitch.
We would like to be big four.
No, I'm with you, but I guess.
But we're actually doing quite well, yeah, growing, because I mean, we're growing, so there's a lot of opportunity for growth.
So let's say Apollo, they're starting a fund, they come to you to underwrite basically everything that they have, or.
Not really underwrite, like, we will issue them a rating, and then it's primarily for pension funds and stuff too. They need rated assets to buy, so these funds wanna get rated so that the pension funds can buy them, that's pretty much it, so. They would approach us and say like, rate this issuance,
And
and
you
we would
want-
put a rating on it, and then
You want
that
the
would-
pension funds to look at you and say, okay, if they're rating them and they're saying
Well,
that they're this.
Well, we would have to be written into their prospectus, so they would say like, when we, they go out and they say like, this is our methodology for how we buy, what we're gonna put into our pension fund. And it'll say, it used to say a lot, it needs to be rated by Moody's or S&P or Fitch. And
Mhm.
we've done a lot of work to get them to add to that list.
Gotcha.
But we're also like a nationally, it's called a nationally
you're real.
You're
not,
real.
You're not just trust me, bro.
Yeah.
Gotcha.
Yeah.
That's it. It's just fascinating because you're part of the verifiability component of all these things. Where if I'm an accredited investor and I'm looking at stuff and I see that I don't know the name of your company,
KBRA.
KBR. If they're rated by them, okay, so then somebody real is looking at them, just like Moody's or Standard
Yeah,
Poor's.
yeah, that's what we're going for, sure.
How does
But I'm
someone-
sort of like, I'm kind of like, so we've got like the business end, so they're selling our ratings, and then we've got the analysts who are doing the ratings.
Yeah.
I'm sort of like, I support a lot of different analysts, so I build the models that they use, so I'm not really like.
you're the one
frontline like that.
theorizing how these models should work?
Well, the models they go through a whole process, right, so there's oversight on those models, and then, the regulators expect them to sort of, they can challenge the models, the board can challenge the models, and they have in the past. And then we have like a model risk management group that like, their job is to challenge the model before anybody else does. So like, most of those interactions with the regulators and the board are talking to the model risk management folks and wanting to know like, hey, are these guys doing the right stuff? So our models need to be like really well documented, and then we've been really working to improve the production level quality of the software that we get.
Mm.
Yeah, and we're focused right now, a lot of cash flow analysis is happening in the company, so we're working on.
Love cash flow.
Yeah, we're working on cash flow analysis.
In what capacity?
Trying to, a lot of that work is done in Excel, but it's hard to sort of drive consistency in Excel, so we're trying to think of other ways that, other platforms that folks can do it. So that's a package that we wrote down.
But cash flow is cash flow. I guess I'm trying to figure out how do you.
Okay, Professor Gates. Well, you need to, so a lot of these structures have a very specific, waterfall structure.
Yes.
So how do you encode that waterfall structure?
Gotcha. Okay, you're talking about that type of cash flow.
Yeah.
Because in my head, I'm thinking, are we talking accounting right now?
No,
Are we talking
I
about
mean, it
finance?
does end up sort of in that account.
Yes.
We haven't started the party without it.
I think
Professor
it's
Hayes.
time.
It's time to start the
It's
party.
time for pie. Bruno's Delivers,
Yeah,
earliest.
yeah, they were a little bit early.
Right.
They were a little bit early, and then I already did my spiel.
Yeah, I
You missed
figured
it.
that. I've reviewed the emails, but they were good.
Yeah. Okay.
Let's take a break.
Let's take a break. I just executed on what you said, so I
Yeah,
don't-
yeah.
I don't really even know.
So there's chicken
There's a
pie.
This is a chicken pie.
There's a New England pie someone requested.
This is a
What's a
plain
New
pie.
England pie?
New England pie
It has, like, shrimp on it.
shrimp and lots of garlic on it.
A lot of garlic.
That's
And
interesting.
then there's a
pepperoni mushroom, and there's a margarita as well.
Pepperoni and mushroom is my type of jam.
I was hoping the mushroom would go for you. I figured it might, because you only mentioned the pepperoni.
I'm not scared of mushrooms. That's a margarita with black olives.
The black olives, yeah.
Somebody asked for New England, lots of garlic.
I gotta know who's
And
from,
that's-
who's
that's-
looking for New England pizza.
I asked that.
Oh, New England?
Where did you have New England pizza before? In New England?
I don't know, I just saw the patio.
Oh, okay.
I had to see the ingredients.
A little box is the New England pizza. Who requested New England? A little box, another little box.
With the, yeah, with the,
How you doing?
doing well. Worked from home today.
Did you?
Great.
Yes, I
I've
had
got some
to.
flexibility there.
What's that?
I've got some flexibility there.
That's good. Well,
Kind of a big deal.
There are drinks in the cooler. We got water here as well, there's soda. Coke, Diet Coke, 3 flavors of seltzer.
So you missed my spiel, it's great.
saw, I was reading your comments. Very impressive work. Better than the typical year, yeah?
I would say so, yeah.
Mhm.
And we came with a 99.
You going in last?
What?
Going in last for pizza?
Pretty good.
No, I'm not gonna eat here.
Oh.
I, Tell you, eat the ring, that's not fair. Quite good, yeah, it's good pizza.
It is pretty good.
Yeah. Good restaurant.
I've never heard of it.
So, I mean, restaurant, first pizza on.
Yeah, it's a little bit flop.
I know that, the Barstool guy, he makes pizza,
Oh, yeah.
and he talked about a spot in Connecticut, I don't know where it is.
Oh, yeah, he loves all that new.
Oh, he partners probably in 100 different places in Connecticut.
Yeah.
And there's a second Connecticut guy doing it too.
Closer you get to Massachusetts, everything tastes better in his eyes.
Well, he's from Boston.
Yeah.
Except he's a big Michigan fan, so I don't know why he's a big Michigan fan coming from New England.
Because I'm assuming it's a strong assumption it's his alma mater, but.
He doesn't seem like the guy who went to college though.
Portnoy?
I bet he does.
I'm pretty sure he's not.
I don't know.
He has to have gone to Michigan.
I don't know why he likes Michigan either. I don't think he went there.
He doesn't seem like the kind of guy who went to college.
You're also right.
Yeah, so
Longer.
77. No. 19 plus 1.
How's the New England pizza?
Seafood is already.
Can't go wrong with it.
What's that? Yeah. Have you spent time there before? I was there for like a conference or. I did work time, so I spent a week. Oh, yeah, it was, it's our studio conference. I took a, with Hadley Brooklyn.
No. Good, huh?
Pretty cool.
Dig into any pizza you like, whatever your preference was. Step up, have a different kind too. Those are all seltzers except for the Cokes and the Diet Coke. Yeah. Yes, it's. all over there. Just running around the track and looking where those barriers. Really mentioned that one in the submission. You're really concerned. Yeah. That's what she said. That's what we noticed. I've had a couple of conversations. After I did read the bill thoroughly, I'll be so proud of you. So this is, maybe my thoughts over the years. Just talk to Gemini and face average, try quality. Maybe it's hard.
It's a little bit.
Right on the fly, right? You know, I don't have as much career base to work with. Yeah, I know, too. We will encourage you to take food home and drinks at the end. You eat to your heart's content, so, we have plenty.
Oh, that last pepperoni.
Every other one.
You ever have a chance?
One week, I'm taking 600. Yeah, no, there's no, I said, there's no project that we can do this job. I was making obviously much easier.
Well,
It's just to make it paste on this.
Yeah. It doesn't, you can be like, oh, this is like,
So I was asking if providing this data from ICE common exchange, physical and financial mutual funds, the one daily file. It's 300 or 600. So, yes,
one day.
yeah, it's like every tick, and it's every physical. But, I asked them, how much do we know? I was only given two, but it's a lot. I didn't wanna give it that much, I only wanted to give a sample so we can, because it's actually three files. It uses Fix, which is financial information exchange protocol, which turns out it's just every row, it's identify 5 equals, and then some of the codes come through, and then they're separated by types. And then what they do is just split them on the right. So it's 5 is telling you the location, 23, that goes on. It did a pretty good job. It wasn't quite perfect, but yeah, I wanna go with Claude.
Yeah. So that's.
Oh, but so we, but only 20, you don't need context. You don't run out of.
So I haven't yet, but I was reading it.
Yeah, maybe not the evidence we were.
Yeah, it shows like, I mean, the book stuff, it's like, you can tell your agent to do the, whatever work. How about like,
Yeah, I
I
think that was
noticed that,
that.
like, I used to have access to all this.
But they've been playing about the services universe. It's using money. Oh, yeah, yeah. I'm very interested. I was working on ChatGPT to go on the roster. I decided to send me that, so I was paying too much money. But it was weird, like, every time I tried to sign up, it said, well, you have to do it, and it's, so, then I canceled it. Pay, renewal, but it could.
Chase here. So I'll do, I'll just, oh, yeah. So what I'll do is I'll just put a.
Which one? I've been so busy, I was gonna make my monthly challenge. On the watch, you get the monthly challenge, right?
Yeah, I don't do that.
You're too far gone. It was a pretty easy one this week, this month, but I've been so jammed up with time. Yes, garbage over there. Mr. Cliff,
Hey,
how are you?
I'm hanging.
So, yeah, the pizza went well. I think we hit the number.
Yeah, that was a good order.
There's an extra pie still.
All right, so I'm gonna hand over the class to Professor Hayes, but this is my finale. So thank you everybody for taking my class this semester, and it was great to work with you all, and good luck and all. And if you need anything, please reach out. You have my email.
Thank you, Professor.
Thank you very much.
Thank you.
A little bit hot range, so prepare yourself.
All right. All right, it's all yours,
Take your
Professor.
time. Enjoy your trip.
Take some pizza.
There is
No,
more
no.
pie.
I'm good.
There's one more slice of pepperoni, one more slice of chicken, and then almost a whole cheese pie. You guys want, I'll leave these boxes in case you want to take half of them at some point later on. Sorry, there's not more ice this time. Usually I bring a lot of ice, but I had some personal matters that interfere with my ability to throw the big party. But I'm glad people got back to me, so I was able to get you your preference. And I have one more lesson for you tonight and some thoughts on how you can go forward from here with your professional and personal aspirations about using machine learning as a tool for whatever you find it useful for, but especially for professional success. And so that was a lot of what we're about here. I've got a couple of submissions on the homework assignment. You can send them to me if you choose to do them. If you don't do them, I won't penalize you, but it's good if you have, we have until next week, before the semester's officially over, I think. It's always good to do some work. That's part of what I'm gonna talk about tonight, actually. I read Professor, he CC'd me on your grade reports. I was supposed to look at that. The old mute button here.
Thank you.
Just throw it there for a second. I think he was quite happy with the work you did, better in many ways than what we've gotten in the past, so I'm glad you got that. So I did send you 2 files. If you're able to get the CSV, that's good. If not, we're gonna go through the code anyway. So I have a couple of book recommendations for you. I guess Professor McDonald goes with a different lighting scheme than me. I guess that's what I usually do, right? Let me just get my notebook up here myself. I probably have that on the computer. Okay, so. Kind of weird now, it doesn't work anymore. Picked the wrong. Okay, so this book by Janis Klaas, Machine Learning for Finance. I looked at this book back in the beginning of the semester, also by James Lee, I guess. I don't know why 2 authors here, only one author on this picture, and I think I rejected it maybe because of the May 2019 publication date. I just figured it was going to be too difficult to really get all the code to work properly. That was, maybe I would give it a second look. This is a nice book. I don't know how much it costs. Packet books in the past, I found they tend to be kind of weak in many packet books. But lately I've been finding that there's actually a lot of good ones too. And sifting through the wheat and the chaff is maybe one of the challenges, but machine learning books have tended to be pretty good recently. So this is an interesting book worth reading. It does not yet overcome my favorite book. Let me go to LinkedIn and show you this guy here. We've talked about Stefan Jansen before, but I'm going to put him up again anyway. Who I've been working with him just on the side of his new book. And if you were going to buy one book, I think this is probably going to be the best value for your money. He has, is that my phone? Usually I have that thing on mute, but I'll put it alive for Professor McDonald's call. Yeah, so, and this has 400 runnable notebooks. I'm not advertising for this guy, I just like his stuff. 100 plus primer articles covering ML, statistics, and quantitative finance, which, as you know from working with Professor McDonald, statistics is a lot of what's interesting about the applications we do for machine learning and quantitative finance, and understanding how the type of information you get out of a model, which is largely a black box in many cases, can be analyzed via statistical methods is interesting. F1 score is going to play an important role in tonight's notebook, and I learned more. I refreshed my own memory about why it's an important score. Now this is, this particular book is really about machine learning for trading. So if you're not into trading markets, or if you're not thinking about getting a job in a trading business, it might not be perfect for you, but it's a very, I know most of us we're in business school after all, have interest in finance and trading concepts, and there's a lot of material in this book which is useful beyond trading. He takes a very scientific approach to how you should be approaching a machine learning project in terms of what you should think about going into it, how you should be gathering data, and how you should analyze the results as you proceed through your project, and how you should maintain a discerning eye to your own biases creeping in and misleading you into believing things that maybe aren't true. As I mentioned, it's the third edition. It's a ground-up rewrite, so it's good. It's going to come out in June now. He was trying to get it out in March, which is what I was kind of hoping was going to happen. And he has a website, which I'll click on now, just to see what's going on there. It's a book, so a structured workflow. This is his thing, a structured workflow for building systematic trading strategies from hypothesis formulation through production deployment. And you can, foundations, features, models, strategy, advanced AI, and production. So there's a pretty good general machine learning flow, which you can apply to other aspects, other applications of machine learning outside of finance. If you're going to run, some kind of marketing experiment and you want to apply a machine learning method, some of these would apply. So it's a good book. I recommend it. It'll probably be relatively cheap. I always recommend Kindle these days. That's my own preference, but I know some people still like the feeling of paper, but I've moved away from that because I have like 200 books on my iPad. I can't carry them all around all the time. Okay, so, but this other book which we're going to talk about tonight, it's a good book. I probably will consider it in the future, though I'm going to be going with the Jansen book probably for most of the time. It's, like I say, it's 800 pages, and it's going to be 2026. This is 456 pages, 2019. And page count is not the only determinant of what's a good book, but if it's quality pages, then you do get a lot of bang for your buck. This one, in some ways, is many short topics, and you can see the first one actually. The one thing we haven't talked about in this class because of time constraints are neural networks based, And we'll talk about that a little bit tonight. And then applying machine learning to structured data. Structured data is what you had for your experiments with Professor McDonald's credit set, right? Structured data basically means it comes in rows and columns. Whether you find it in a spreadsheet or you find it in a database. That's what structured data is. To be compared to instead, let's say, visual data, right? If you're trying to train something to spot a cat from 100 miles away, there's a whole different set of skills that are involved. Structured data responds well to tree methods, and particularly we highlighted gradient boosting machines last week. We'll see this example played out in, I think, a little bit better way than we saw in last week's class. Neural networks are applied for more complicated problems, which, like for example, the self-driving cars that you see out on the streets are definitely using neural networks at the heart of their calculations. Because and one of the things, neural LLMs that we're all working with, Gemini, Claude, etc., are all based on neural network types of organizations. The key to make what's made Gemini and ChatGPT so successful is they have on the order of hundreds of billions of parameters, or maybe even trillions of parameters at this point, which get tweaked to answer like a lot. Every question you ask, it's got an opinion, right? And most of the time, its opinions are well informed and well written. But in order to be able to fit a model that has, let's just keep it simple, 2 billion parameters, you really have to have a lot of data to train on. And today's large language models have trained themselves on the entirety of all human information, largely speaking. Anything that's written down somewhere, these things have read, sometimes without permission. Every New York Times article, every whatever 30 million pages are in Wikipedia, every volume of Shakespeare, every ancient philosopher, probably every language that has written stuff, it's been there. But which gives people concern that they may be topping out, because if you've already read the entirety of the internet, who's going to make the next internet except more ChatGPT writing each other?
But doesn't AI just access it, they don't actually retain it?
Well, so they, like a simple way to understand how an LLM would be trained is it starts reading Wikipedia on page 1, whatever, with some ordering scheme. And it reads the first word, maybe even the first letter, but probably the first word, and it tries to guess the next word. And then it tries to guess the next word. And it goes through the entirety of Wikipedia, guessing one word at a time. Of course, the first time through, it gets almost none of the words right. Okay?
How long does it take for it to go through that?
It will take it like maybe on the order of 4 or 5 months to train the model, which means potentially thousands of GPUs and warehouses performing these computations. But so however long it takes to go through once, it will go through it many hundreds of thousands of times, I suppose, or millions of times. And each time it goes through, it knows which words it got wrong, which words it got right. And eventually, and every time it gets to the end of the path, it doesn't necessarily run the whole Wikipedia and then start passing information back. It probably runs a snippet, what's called batching. You guys know what gradient descent is? Gradient descent's an optimization technique. The simplest example is you think of a big bowl, like a parabola, but in 3 dimensions. And you want to get to the bottom of the bowl. Gradient descent says that the tangent plane to the bowl is the direction of steepest ascent. That's a calculus 3 topic, which is if you want to get to the top of the hill, go straight up as quickly as possible. But then you take a step and the hills kind of change contour and you shift over. Well, for a parabola, of course, it's very smooth. But gradient descent says go the opposite direction of the gradient, which gets you down to the bottom. So that's a technique for training. This is from Stefan Jansen's book. He gave me 50 gigabytes of data, which I had to temporarily store on Dropbox, which is where he gave it to me from. But it's reminding me that I'm going to lose it. So gradient-based optimization is that you've got a loss function. In the case of linear regression, it's the mean squared error. In the case of logistic regression, it's the log loss function. Typically those are the two most commonly used loss functions. And what happens with, so if you're gonna do pure gradient descent, you'd read all of Wikipedia once, and you'd find out how many mistakes you had made, and then you'd calculate the gradient and pass that information back through the network of matrices that are multiplying each other, and all the weights would get tweaked slightly. And then you start over again, and you run the path again. So, you know, the first 1,000 times, you don't get anything right. Then the second time, you know, you see the words in the beginning, and you know, maybe you say was the word, or in the beginning, you know, Tom pushed his friend Huck to steal the apple. Whatever, you know, whatever story. You know, it gets better as it goes along. Now, batch gradient descent says, okay, well, if you wait till you do all of Wikipedia before you do your optimization step, you got to wait a long time. So instead, we send in, you know, 32 Wikipedia words, or 32 Wikipedia pages, let's say. And after that, we tweak our weights. Then we pick another 32 pages at random, and we tweak our weights. In this way, you know, it comes up with the optimum model. So that's gradient descent and neural networks. But for many problems that you'll see in your life, if you try to apply a machine learning technique to your data, you'll probably be looking at structured data as opposed to, you know, the Waymo car riding around the street. It's getting LiDAR sensors coming from everywhere, so the data is highly unstructured in that regards. And we'll find gradient boosting is a good idea. So in the sample notebook that I sent you, and when I went through the notebook before class started so that any glitches in the old, let's make this bigger, in the old code would be fixed. And one of the things you're supposed to have, so he, for whatever reason, when he created his repo, had the input directory sitting on top of the directory we're in. In fact, you can see here I'm in my PyCharm projects. This is I downloaded the Git repo, so I had this notebook sitting in machine learning for finance. Again, as always, the notebooks are available for free. You can make a lot of progress just by reading through the notebooks. But I dropped my data file. I created, I don't know, this didn't make sense to me, so I just made an input directory. So if you go look at my file manager here, my finders, we say in Apple World, you'll see that I created the input directory as part of the machine learning for finance, where he has it one level higher, i.e. he has input at the same level as machine learning for finance. So yep, from the notebook you have to go up one. Oh, I wish I didn't screw something up there. Anyway, hopefully you have your own understanding of how network structures are fixed. And this file, he gave a link on the O'Reilly website, which I couldn't, which was no longer valid, but I searched for the topic, which is, the data set is called PaySim. It's a set of data created by somebody to simulate a stream of mobile payments. So people in Europe, as you may be aware, have been doing mobile payments for quite a long time, whereas people paying for things with their phone is still relatively uncommon here in the States. It's becoming more common. I like to pay for things with my watch. Double click on the watch and it comes up, it works. You like it?
To this day, I still don't have it up
Yeah.
on my Apple Watch.
I never got into doing it with the phone, but I did get it with, I do with my watch. Once in a while, I'll use the phone at the ATM, for example, but, only,
You use it at the ATM?
yeah, you can use your Apple phone, you know, you can use your Apple.
I've never used it at the ATM.
Yeah.
I use it at the cash register. I've done it once or twice.
You use it at the cash register too, yeah. You know, but the only thing is, when you change cards, then you gotta kind of scroll through and find the card, which is why, you know, I just have the Apple card right now on the watch. Actually, I changed the credit card on the watch, but it's very convenient, except if you forget you leave your phone in the car, your watch does need to talk to your phone and you're
Correct.
clicking away, so I do keep the credit card in my pocket as well. So anyway, when you go, so part of what I'm going for in this particular talk is I want to encourage you, like, how do you get better at this topic? How do you actually take it from I've learned to do something in class, I've learned about something in class, I've done some homework perhaps. How do I get to really use this in my life? And the answer is, well, when you're not taking classes, and you have a little more personal time, that's the time when you don't want to stop. I mean, you do want to attend to your other parts of your life, whatever your hobbies are, your family, or your, you know, your kids' hobbies, etc. Right? But it's also a good time to find a good, you know, technical book if you want to become more technically proficient. Find a good technical book and really work through read the book, understand it, and work through the examples. And by working through the examples, you begin to start to understand why these things work the way they do, and you begin to see maybe this is something I could apply at work. Now, what would you use it for at work? Well, I guess it depends on what you do. But if you have a situation where you notice that, what would you notice at work? You might notice that a certain customer, whenever they buy something, leads to them buying other stuff. Maybe you could go through the data of their purchases. I don't know. You have to think of it for your own job. Okay, I know how I'm going to use it at my job, which is about trading natural gas. But that's, you know, can't tell you that because it's a secret, right? Okay. But not everything is a secret. So you know, again, you know, all these. There were actually two things I had to install here. I forget what they were, but I had to do this TDQM. Usually once you've done so how do you install something on the fly, right? You just add a line in the notebook and you just say, you know, you hit this is called, people usually call this bang. I just call it exclamation point. But bang, you know, pip. Bang means I'm gonna execute an operating system command at the in this cell. Pip install, and you pick something like you'll need TensorFlow for this, but I already have TensorFlow. It's going to probably, it should tell me that. And it says, yeah, already got it, okay. And then, you know, once you do that, you do want to either X out, I didn't X them out because I wanted to save them for you. You would hit the little scissor, get rid of the cell, okay? I got rid of the other cell too, the TQDN. I think I need an XGBoost in this particular library. I happened to start up in the library that, one of the Python environments that we created for this class. And using the thinking of our prior author, we're using Matplotlib. There's something called MPL toolkits. Seaborn, as I mentioned last time, is the Python port of the Hadley sphere, the Hadley-Wickham nice look and feel of his diagrams. sklearn's been around a long time. XGBoost stands for Extreme Gradient Boosting. As mentioned in many books, is the second most popular way to win competitions on Kaggle. When you know, if there's really a lot of data, you probably need a neural network. But if it's any kind of tabular problem, you're probably going to win with XGBoost. And I don't even know what TQDM does, but we need it. Okay. And so what do we have here? He creates a method, right? He writes code. He writes nice code, actually. So remember, in Python, def means I'm going to define a function. So he defines a function called plot confusion matrix, and he says, I'm going to pass an object called CM, some names, CMAP and normalize equals true. CMAP is related to the color scheme you're going to get. And he tells you what you get. Given a sklearn confusion matrix, make a nice plot. So he wants to use these confusion matrices in these notebooks. As you probably have learned, they're useful, right? They tell you a lot of information, especially in your 2x2 case, true and false. And this gives them a way to make it nicer than what you might just get right out of the box, okay? And to, you know, and this is what you do when you have your own time, right? So let me learn what this thing is, and let me understand how we did it. Even though you're going to ask GPT to do a lot of things for you and to tell you to do things, there's no substitute for contemplating, well, how did this happen, right? And because even though today, if you understood this notebook, you could then say, look, GPT, I've got this data set, here's what I want to do. And you could interact with it, you could tell it to do these things, but you can't do that unless you understand what it is you're trying to do, okay? And whereas, you know, like I say, 2019 when this book was written, you didn't have to look up a lot, what is EDR tools, what does it do? Who knows, right? But now you don't. So accuracy, it's defining. So anyway, this is just how to make a confusion matrix, okay? And you can review how that's calculated. What is a confusion matrix? You have to tell me off the top of your head.
Shows true positive and false negatives and false positives.
Right, 4 quadrants, right?
Yeah.
It's got, you got your, well, we're gonna see a nice one here when we get to it. So it gets the data, and, as every author will recommend, you know, if you get some data, well, you should go take a look at it. What does the data look like?
That's
This
quant
data.
stuff though, right?
What's that?
That's all quant stuff.
What?
The confusion matrix, that's part of like quant statistics.
Well, so the question is like, you know, so you get this diagonal, right? The ones that are on the diagonal, it means that the property held, it's true, and you said true, or the property didn't hold and you said false, so those are good answers. And then the off-diagonal ones are your type 1 and your type 2 errors, basically. One of which is, OJ goes free. That's a type 2 error, I believe. Type 1 error is rejecting a true hypothesis. Type 2 error is failing to reject a false hypothesis. In American legal system, you're innocent until proven guilty. So the hypothesis is he's innocent. Turns out that's false, but you fail to reject, that's a type 2. Okay, so this thing is, so let's take a look. There are payments, transfers, and cash. Yeah, so like I said, this PaySim just generated, I believe there's 6.3 million rows of pseudo transactions. It's just invented data. And it says that, okay, there was a payment of $9,000 starting at this account. The old balance in this account was $170,000. After it makes a payment of $9,800, its new balance is $160,000. The destination, so the payment went from C to M. The old balance started at 0. The new balance started at 0. I don't know why. It doesn't actually pick up the $9,000. And is it a fraud? It's no. Was it flagged as fraud? It's a no. So these transactions, some of them designated as fraudulent. And what you've got here is a model that had some information about what was fraudulent, and also has already made a prediction as to whether they're fraudulent or not. Okay?
So it is guessing if it's, or it's hypothesizing if it's fraudulent or not, or it knows that it was.
This is a synthetic data set. So the ones that say it is fraud are that's taking the ground truth. If it says it's a fraud, it's really a fraud.
Got it. And flag fraud is one that they selected as fraud.
Right, which I guess means there was some other model. Let me look up what the text there. One second here. Yeah, so is flagged as fraud is whether or not the old system flagged it as fraud. So you're writing a new system to try to predict fraud, and you've got an old system, so maybe there's some information in whether the old system thought it was a fraud or not, okay? But you can see there's a couple of frauds here that were not flagged by the old system. That's clearly what we're gonna try to replace, okay? And they decide that we're only gonna be interested in transfers or cashing out. We're not interested in payments. We assume, and we end up with a data set that has 2.7 million rows. So they eliminated the payment type, and then they get the number that are fraud or transfers, the median. So there's 485,000 that are either frauds or transfers. Let's see. These are Booleans, right? We talked about this masking thing. So first of all, you find out if is fraud is a 0. So that means it's not a fraud. And is it a transfer? And then you take the amount, take the median, So that must be somehow that somehow counts these 486,000 out of 277,000. All right, so the fraud heuristic, okay, so then the book is kind of interesting. He says, you know, how can we solve this problem? I've got a lot of transactions. I need a new system that tells me whether or not I should be flagging fraud. So the first thing it says, well, a heuristic is simple. A human being makes heuristics, which is, I'm just gonna take some kind of expert knowledge that I have, and I'm gonna use that to build a quick and dirty system that enables me to reject some transactions. And the particular heuristic that this guy comes up with is, all right, we're gonna call it a fraud if it's a transfer and the amount is greater than 200,000. So that's our quick heuristic, okay? And in that case, look at what we get. The fraud heuristic sum is 409,000. So this looks like we're doing pretty good. I think this says we're getting 409,000 out of 485,000. And yet the F1 score is only 0.13. Now what is the F1 score? How does the F1 score work? Raise your hand if you know quickly how the F1 score works. You've heard of the F1 score.
I've heard of Z-score, F-score. I don't know if F1 is the same score as F-score.
No, the F1 score, I know it's probably in Professor McDonald's notes, not criticizing you, because I looked it up myself today. I said, you know, I've used this F1 score before, but I never really thought about why. Let me just, you know, nowadays knowledge is easy, right? So. Okay. Let's see here. One second, I got another, latest talk with the harmonic mean F1 score. Okay, so I asked it, why is the harmonic mean? Let me tell you what the harmonic mean is before we even go there. So the harmonic mean is this formula. H, the harmonic mean. So there are three kinds of means. There's the arithmetic mean,
Geometric.
the geometric
And
mean.
harmonic.
Right. So the arithmetic mean is the one we use all the time.
Mhm.
Add them up, divide by n. The geometric mean is you
The inverse of.
you multiply all the numbers together and take the nth root. So it's another kind of mean. And then there's the harmonic mean. What you do with the harmonic mean is you take all of your data and you turn it upside down. You take its reciprocals. You take the reciprocal and add them up and divide by n, which would be the average of the reciprocals. And then you flip it over again, and that's the harmonic mean.
Okay, so I guess my question would be, what is the purpose of this harmonic mean? What
This is exactly why, or to the same point, what is the purpose of the F1 score? Because it turns out the F1 score is just the harmonic mean of precision and recall, which we're going to see in one more second. So, but it says, look, if there's only two values here, the formula becomes simplified. It becomes 2 over reciprocal of the first, reciprocal of the second. Then you get a common denominator. Just to remind you how you want to add fractions up. This is the common denominator, x1 times x2. And then if you have a fraction on the bottom, you flip it upside down, it goes to the top, right? And this becomes the formula for the harmonic mean when there are two ratios being compared. And then finally, in the definition of F1 score, we're going to come back to that. The F1 score, P is x1, R is x2, the precision and the recall. So this is the F1 score. 2 times the precision times the recall over the sum of those. So that's what the F1 score is. And then the question is, why is this interesting to us? And before we get to why, let's just go take a look at, let me get back into the book here for a second. Okay, so here, we have the definition of precision and recall, and I highlighted them to remind myself. What is precision? It's the number that we say are positive cases, frauds in this case,
True fraud.
divided by all of the things that we said were frauds. So this is a question of, if I tell you it's a fraud, what percentage of the time am I correct that it was a fraud? So there's 100, if I said 100 things are fraud, and turns out 90 of them really were frauds, my precision would be 90%, okay? Then the recall is the share of predicted positives over the actual number of positives. So what's really a fraud? Either it's a fraud, true, and you called it, so it's a true positive, or it's a fraud, but you said it's not a fraud, so you have a false negative, right? Because that's the recall. So now we say, okay, well, if I give you a bunch of data and I ask you to identify all the frauds, what percentage of them are you gonna get? So I gave you 1,000 frauds and you only flagged 100 of them.
Pretty bad.
And only 90 of them were right, by my previous example. So you're only at 9%. So the idea of, we want our model to be precise. When it says it's a fraud, we'd like it to be a fraud. We don't want to inconvenience our customers. We don't have to by flagging their transactions. But on the other hand, we don't want to miss, it's easy to get it, it's easy to make recall, it's easy to make accuracy high, right? If you,
Because you could ask for everything.
well, no, these frauds, these credit card data sets or similar type fraudulent transactions, they tend to be highly what? What's the word for the fact that you got millions of good transactions and only hundreds of fraudulent ones? What do you call that when a data set has a lot of category A and only a few of category
It's not balanced.
Imbalanced, right? So credit card data sets are highly imbalanced. There's a lot of transactions, there's very few frauds by comparison. Vaccine data is similar, right? Let's say AIDS testing, right? You know, there's a lot of, most people, let's say, don't have HIV, but, am I giving a good example here? Let me see.
That was the problem with the first COVID tests.
Right,
That's where they had a lot of trouble.
explain.
Because there are so many negatives, the fact that you got a negative test didn't really mean anything. Well, they got a positive test, but it didn't really mean anything. You had to do multiple tests to really confirm whichever way it said. Because it was so imbalanced.
Yeah, either it's precision or it's recall, we're not good enough, right? Yeah, so like if you're testing for a rare disease, let's say, and so in the population, maybe only 10 people out of 1 million have this rare disease. So most people that you test are going to give you false, they don't have the disease. But if you test 10,000 people, you might come up with 100 people who have who test positive. So you have a lot of false positives, just because the test is not accurate enough to be able to find those things. So precision and recall is about balancing these two features. And the way you balance the two of them is, so the thing is, you might say, let's take the average. If I'm 90% precise, but 0% recall, then my accuracy would be, my average would be 45%, let's say, right? With credit card receipts, let's say 99.5% of the transactions are good, 0.5% are bad. So a way to be accurate would just be always say, yeah, they're good. It's a good transaction. So our precision would be 99.5%, but our recall would be 0. And our average, we might say, is that we're 50%, which might seem like it's a mediocre model, but it's not horrible. But in fact, it would be horrible because you missed all of the transactions. So the F1 score takes the average of those two things And it turns out you always get a number between 0 and 1. And if it's near 0, what makes this fraction equal to 0, let's say? What makes it equal to 0? This is a little math exercise in your brain. How do you make f1 equal to 0? If a fraction's 0, the numerator has to be 0.
The precision of recall is
If a
zero.
product is 0, one of them has to be 0. Or if one of them is very small, that will make the product near 0. Whereas if they're both like 90%, for example, then the top's going to be 90 times 90 is 81, and this is going to be 90 plus 90 is 18. And is that right? I probably have a decimal. Let's say they were both 90%, 0.9. Then we would have 0.9 times 0.9 divided by 0.18 equals 4.5. I must have one of them in wrong scaling, because I'm getting 4.5. I should be getting something that is between 0 and 1. So I guess they can't both be.
No, you're right, because you got 0.9 times 0.9, that's 0.1, and then 0.9 plus 0.9, 0.18.
Right, that's 4.5, but that's too high. It has to be between 0 and 1.
You're not multiplying though.
Well, multiply by 2, it gets even bigger.
It's not what we want, but.
Well, no, I need the number to be between 0 and 1. My number's coming out to be like 5 times 2. So you put 0.9 times 0.9, you get 0.81.
Yeah.
The bottom is
Oh, divided by 0.18, okay.
0.18, you get like 4.5.
Yeah, that's right.
And you double it, you're gonna get 9. So it must be impossible for them both to be 0.9, for a reason that we'll have to do some math. Okay, anyway, so the deal with the heuristic is it's easy to do. So you can see here, it shows this line of code here is the one we saw from the notebook. Let me pull this over here. Okay? And so the F1 score is a very low number, which means that this is not a very good model. Okay, now the benefit of the heuristic model is it was fast. It only took us 10 seconds to think it up, and we got some of the frauds. Let's look at the confusion matrix. So this is a good, he did a nice job of drawing this confusion matrix. Actually, there's a way to make this thing hide, but it's not. Okay. So there's the true label is genuine transactions versus frauds, and the predicted label, genuine and fraud, right? So what do we have here? On the diagonal, we see, it gets a lot of them right. On the, there's 5,000 frauds that he say are genuine, and 2,700 frauds that he say are frauds. So what's,
False positive, true negative, false negative?
this is true positive,
True positive,
true negative,
true negative.
false, false positive, and false negative. So if you put those into your precision and recall, you get the scores that you need, and you'll end up with, so the accuracy is 85%, which seems kind of good. Misclassified 14%, but accuracy is not good enough because the precision captures the fact that, the recall captures the fact that we only got 1/3 of the frauds. So we probably want to say, I'm not happy missing 2/3 of the frauds. Now, I don't know what the old model was doing. On the other hand, it only took us 10 minutes to come up with this, and now we have, now we're getting 1/3 of the frauds. That's a good start, okay? We're actually flagging a fairly high number of genuine transactions as fraud. That would be, now that, look at this, this is 400,000 over, let's call it 2 million. So roughly 1 out of 6 transactions are being flagged as fraudulent. So this would mean you go to the store 6 times in a day, you're guaranteed to get flagged once. And people say, I'm sorry, sir, your transaction is not going through. You put your head down and you say, I get another credit card. Or try it again. Hopefully I didn't spend all my money already, right? So this is a sign that we rejected. So he comes up with says, okay, the second thing we can do is we can put more brain power into this. And putting more brain power what he calls the feature-based model, okay? Relies heavily on humans modifying the data to create new and meaningful features. So we have to look at the data, we have to have more experts in the room, they have to think harder about this problem, and they might have to spend some time that they could feed into a simple machine learning algorithm. This mixes expert knowledge with learning from data, okay? And then the final kind I'm going to talk about is end-to-end model, learns purely from raw data. No human expertise is used, and the model learns everything directly from observations. Famously, Jim Simons, Renaissance Technologies, reputed to be the best ever trading shop in the world, supposedly learned everything from data. Okay? Maybe it started by doing feature-based modeling, but then moved more into end-to-end modeling. Okay, so this was our heuristic, $200,000, and we see, well, it's not that good. Okay, so now let's see what our next, he makes a nice little picture here. This is a heuristic picture. You know, how much time does it take? It takes almost no time at all to come up with a quick heuristic, but, and the performance is only so-so. You put a lot of time in, maybe you come up with good features, and you come up with a good model, which maybe will have an F1 score that we deem more acceptable. Maybe we get 75% of the frauds, and maybe we only reject 5% of the valid transactions, or 2%. I don't know about your own experience with credit cards, but it's rare that I get a call on my card, I get a transaction flag. I had one today. I bought a book on Amazon, and which I've done a million times. I used my Amazon card for it, and it got held up, and they asked me to apply a new credit card. And I had to keep on telling it, no, just keep using the Amazon card. And finally, it never admitted that it processed the transaction, but then I saw it appeared up in my orders as having cleared, and now it sits on my iPad as I wanted it to. So a rare miss, I would say, by the Amazon model, which Amazon, of course, probably does more transactions than almost any business in the world, right?
100%.
I mean, Walmart would be the other candidate, right?
Maybe.
Yeah, they got a lot of stores. You ever going to Walmart on Saturday afternoon?
I do not. I'm a Costco guy. I've graduated. Costco and BJ's.
Well, you've been to Costco on a Saturday afternoon? It's not
No,
that-
that's
it's not
nuts.
that different, but Walmart
That's
has like 100 times as many, right? You know,
Mhm.
and they're 5 times as big, whatever. But Amazon, of course, they've been doing, gazillion transactions, which gave them their best business of all, which is large computing centers, right? Which is the Amazon Web Services. Okay, so let's see what the next model looks like. And he comes up with the idea, let's break all. So now he's gotten the thing down from 6 million rows to 3 million rows that he thinks are interesting transactions, and he comes up with this little graph. So this is pretty neat. And the author, like I say, he does write a good book, or they do write a good book, because this is a nice story. It says, look, we're going to break the transactions down by hour. When did these transactions occur? Keep in mind, this is only a synthetic data set, so I don't know how much thinking went into the data set. There's a paper about it. But what he finds is that real transactions, not many things are happening at 2 o'clock in the morning. Yes, you do have those who go to the QVC at 2 o'clock in the morning and end up in...
I literally spent $500 on a bat for my son at 2 o'clock in the morning.
Did you?
Yes.
Okay.
But that was also probably after about 2 Makers and Gingers.
Well, that's, I'm surprised it was not flagged, but apparently they maybe know you better than I do, I suppose. And said, no, this guy likes to shop it too. But the observation from this data set was that, frauds, real transactions happen a lot in this particular model, starting at 8 in the morning, kind of hitting a nice peak at noon, and then hitting a real peak around 7 or in the evening, and then tailing off at midnight. Whereas frauds, according to this data set, happen pretty much at the same pace all day long. And these are probability distribution curves, basically.
What time zone is this based upon?
Well, timestamps would always be tied to the time zone of the person, right? So if your credit card is being, issuing the transaction in Chicago, it would use that. So these are relative to local time. And this is actually a probability distribution function. If you think about it, there's 24 hours in a day, multiplied by 4%, you get like 96%. So that thing will integrate to 1. It's probability distribution. This probability distribution, very little happening, and then all of the mass between, you know, the normal hours of 8 and 11. And so now it comes up with a heuristic. It says, okay, this is a feature we might use, which is we might hypothesize that transactions that happen at this time are much more likely to be fraudulent relative to the middle of the day. That's kind of the next heuristic he comes up with.
Who the hell's spending all that money at 10 o'clock at night?
Well, you know, people, you know, the kids have gone to bed, and people are shopping, I guess. You know, it's
People like me to
synthetic
stay up
data.
all night.
$500 bets at 10 o'clock.
What time do I email you at night sometimes?
It's late, but you know, but I would guess you'd have your parents type. Kids have gone to bed at 17. 17 is only 5 o'clock, right?
Sir,
And then
you're thinking too archaically. That's prime drinking.
it's 5 o'clock, and then this is, well, yeah, there's also between
You're at the
15 and
bar.
20, 8 o'clock. This is only 8 o'clock at night. You know, the peak is only 8 o'clock at night. And yes, there's also a lot of socializing going on in those hours.
Mhm.
Okay. So this gives a, you know, this is an example of a feature, and then the share of fraud. Let me see what this one is here.
Share of fraud. Oh, I guess that's the time again?
Yeah, 1 second.
Yeah.
Yeah, this was a feature from Intuition. Fraudsters don't sleep. We can describe them intuitively as shady people who operate in the dark. That's this, they're still going. And then he just gets the percentage of transactions that are fraudulent relative to other times in the day. This suggests that at 4 in the morning, 60% of all transactions are fraudulent. Again, synthetic data, you know, that's probably it. And the data set was probably created to illustrate these ideas in many ways, not by this author, but. Another insight that they come up with is that the fraudulent transactions are often they first do a transfer and then they do a cash out, and he goes on to conclude that what's his conclusion here? So he says, I think what would happen is people will get money transferred, and as soon as they get the money transferred, they're gonna boom, go to ATM and get it out. That's gonna be their MO. But he concludes from these data that that's not really happening, and the lesson here is, just because you think something's a good idea, doesn't mean it is a good idea. So you have to test your hypotheses and see whether or not you want this feature to be in your model. Because if you put bad features in your model, then they become distractors for getting the answers right, and you might spend months of time trying to figure things out. All right, so he goes through a number of these, this story. If you read the book, you'll get a chance to see it. And in the end, let's see what he comes up with in terms of a model. So he does that. This is only chapter 2 in this book. So he's introducing all of the relevant machine learning concepts that you've already seen, probably twice now with me and Professor McDonald. You know, dividing your training data set up into a test set and a training set. And he goes into the discussion. So the test set is really supposed to be saved for the absolute last model when you think you have a good model. Because there's a tendency, you would be tempted if you think about train, validate test, which is the third split. You just think, all right, I'll train a model and I'll see how it does in the test. And if I don't like it, well, I'll train a different model and I'll see how it does on the test. And what's the problem with doing that? Think about this. Let's just say I told you, you gotta keep a test set, 20%, right? So let's say you've decided you're gonna use a random forest, and you're trying to figure out whether you need 50 trees of depth 2 or 100 trees of depth 3. You're trying to decide between a few different choices. What might you do? You might say, okay, well, here's what I'll do. I'll try the different choices on the training set, and then I'll see how it performs on the test set. And I'll use that information maybe to tweak my model a little bit. The problem with that is that you've now taken test information and you've leaked it into your training process. And your test is no longer pure. Like so it sounds like, look, I'm using some model of stock prices to predict what stocks I should buy for next year. And what I do is I use all the data up until January 1st, and then I make predictions for next year. And then I let that year in and keep doing it. But along the way, I do things like I say, well, should I use like a 3-day moving average or a 5-day moving average? Or should I use the commitment of traders reports? And along the way, you make selections based on how well they did. What you've really done there is you've leaked the future into your decisions in the past. And you've effectively tricked yourself. This is where the validation set comes in, where you just say, okay, what I'm gonna do is I'm gonna try all my models. I'm gonna take my 80-20 split. The 80, I'm gonna divide it into 70-10. And I'm gonna use the 70 to try to get the 10. And then I'll play around with the 70 to keep trying to make the 10 better. And then only when you're done, you say, okay, now let me see how I do on the test. Because this is your last chance to say, okay, even though this model looks good to me, it's actually junk, and I probably need to go back to the drawing board. Another thing that you'll read about if you're in the context of machine learning for trading, right, is that if you test 100 hypotheses about, what's a good way to pick stocks, you're probably going to find 5 of them will pass statistical significance of size 5% just by randomness, right? You're familiar with the idea that a result is statistically significant if it wouldn't be seen, if there's only a 5% it would be chance seen by random, right?
But isn't that, you are the one that put that, limit on it?
Well, when scientists try to, try to show stuff with statistics, right?
Yeah.
They compute the p-value.
Well, like confidence intervals, like you're 95%.
That's it. Yeah, but no, the p-value is like, what's the you have the hypothesis, the null hypothesis, and you have the alternative hypothesis, right?
Mhm.
And the goal is, you want to make a null hypothesis that can be rejected. And what happens is you collect data and you say, the null hypothesis, there's only a 5% chance that the null hypothesis is true, given the data I've seen. Like, let's say the average height of the people in this room is like 7'2", right? 7 feet tall, right? So that's the null hypothesis, right? Well, we sample here and we get 0, right? And even though
You fail to reject.
no, so you would reject, right? There's a 0% chance that the null hypothesis is true. You would reject it, right? But the 2 standard rules are, if there's a 7% chance that it might be true, like one person happened to be 7 feet tall, we might say, well, I'm gonna have to reject the null hypothesis. I'm not able to reject the null
Oh, you
hypothesis.
fail to reject.
Yeah, I failed to reject, right? 1%'s a much more rigorous standard, and but it's harder to find things that you're 99% confident are actually true. But if you do many tests, if you test 100 ideas at the 5% hypothesis level, purely by randomness, 5 of them will be true on average. So you'll say, oh look, I tested 100 ideas, I found 5 really good things. I'm gonna tell my boss we should put these models into production and we're gonna start making money like it's going out of style. And then they just turn out to be like randomly true and you don't make money. Maybe if you're lucky you don't lose money, but usually luck and losing money don't go together. Okay, so you get your validation set. So he takes the test here, and what he does with the train, so he gets train and test from the original data, and then he takes the train and breaks it up into train and validation. And that's the other way, what was the other way we saw to do this? What's the other common way to fit the model using only the training data? The other technique besides putting aside a little validation set is to use the cross-validation.
Yeah, CV.
Right, where you take,
5 or
you
10.
partition your training data set into 8 pieces, 10 pieces, let's say. I guess 5 is a pretty common number. Into 5 pieces, and you use 4 pieces to fit the 5th. And you do that 5 times, and you get an idea of how to make your model the best possible. Okay, notice I had to install this IMB Learn, which is a library for learning imbalanced data sets. Okay, this is what we were talking about with the credit card transactions, which is when the data set is imbalanced, you need to have special techniques to just avoid always rejecting, always accepting a transaction. So I'm gonna get rid of that by putting a comment here. And then there's this interesting, I've never seen this technique before, the so-called SMOTE data, the SMOTE method, which comes from this imbalanced learning set, is it tries to take, so you've got, 3 million transactions, and only 7,000 of them are frauds. And you want to oversample the fraud. So you want to make the probability that a fraud gets included in your training set more likely. So the SMOTE data set is a way to reuse a lot of the fraudulent ones in a way that doesn't bias the test from being accurate. And notice what you have up here. This is me doing ChatGPT or Gemini. He had this command fit sample, and Jupyter said, I don't know what that thing is. I can show you. So all of these places where we've got things commented out, that was me. I had this one originally. And it says SMOTE has no thing called fit sample. So you just cut and paste that right into GPT. And it says, yeah, that's because it was named resample. Before I did that, I tried to do it on my own. I came up with, well, I know fit is a thing, but fit doesn't work on, you cannot unpack a non-iterable SMOTE object. That's because I'm trying to create two things, and SMOTE is only giving back one thing. And that's why that didn't work. But this way did work, okay? And then I had a different problem where one of my models wasn't working down below here. And it's, I asked Gemini, and again, not to harp on this point, but had this been 3 years ago, I'd be maybe an hour on Stack Overflow trying to figure out why this thing isn't working. It told me that Keras, the library that controls TensorFlow free, doesn't like 64-bit numbers. It much prefers to work with 32-bit numbers. And sure enough, when I rewrite my data down below here as 32 as opposed to 64, we'll see it. It works better. Okay, so Keras is a library we discussed last week. I showed you the author's book, which was written to simplify access to TensorFlow, the original neural network library out of Google. As I said, Facebook came up with a different library, PyTorch, which tends to be preferred in academia, i.e. here at the university, but which also has a pretty substantial use case in the general world too now. But TensorFlow and PyTorch both have a large market share, mind share, as they like to say, for deep neural network training. If you're going to do TensorFlow, you're going to need Keras on top of it. So just a brief digression on what is a neural network. Here's my Remos Pizza tab. Okay, so Geeks for Geeks. Trap me again. I don't want to download your stupid free software, whatever it is they're trying to get me to do. I don't want to do it. Okay. 12 types of neural networks in deep learning. We'll look at this one here. No, you got me. Advertising. Okay. Okay, so I think I showed one of these diagrams before, but the fundamental concept of a neural network is that you have an input layer, which is a vector. What's a vector? It's just a long list of numbers.
Mhm.
So if your data is an object that's not a long list of numbers, you come up with a scheme to make it into a long list of numbers. It's called flattening. Simplest example would be if we had a picture from your phone, which might be, 1,000 pixels on the side, so 1,000,000 pixels. If you're going to feed that picture into a neural network, which would try to decide what was in that picture, which of your friends made it into the picture, for example, it would take the 1,000 rows and 1,000 columns, and it would create a 1,000,000 long vector, so one-dimensional vector. And then always there's an extra number. Let's just leave it at that. So this blue represents the 1,000,000 pixels in your photograph.
Bless you.
And the original image recognition problem was done by Jan LeCun at NYU, who eventually went to Facebook and became the Nobel Prize winner for his contributions to machine vision. But he did it with handwritten digits from the US Post Office. 70,000 numbers from 0 to 9, split equally into 10 classes. And he trained it how to recognize what the correct digit was. And those pictures were 28 by 28. So he first unfolded them into a 784 by 1 vector. So that goes in to this yellow. Now what does this yellow thing look like? So this looks like 3 things came in, 4 things came out. So these are going to be 4 new numbers, but what those arrows represent, the lines connect them, represent matrix multiplication. So if you've ever taken a linear algebra class, you know that you take a matrix, multiply it by a vector, you get another vector. I was actually going to make that the theme of this class, to teach some essentials of linear algebra and calculus relevant to this, but I decided
How to drop it like a bad habit.
I decided that I would not do that. But suffice it to say, matrix multiplication, a matrix is just a grid of numbers.
So that's not like a probability distribution.
No.
where it's
It's just a grid of numbers, rows and columns, all numbers, but it's not really row and column oriented in the same way a spreadsheet is. There's just a lot of numbers in that shape. And a matrix multiplication takes every number in that matrix, multiplies it by every number in that vector, adds them up, and generates new numbers. That's the result of a matrix multiplication. Usually you take a square, which is a matrix, multiply it by a vector, which is a long column, and you get another long column.
okay.
So and what you've done at that moment is you've transformed the original column into a new column.
You like scaled it or
Yeah,
something.
you've done a lot of things to it. In linear algebra, you might have shrunk it or extended it or shrunk it. You might have rotated it. But now these are 1,000,000-dimensional vectors, so this is happening in 1,000,000-dimensional space, where the word space is just meant to suggest an analogy to the 3-dimensional space in which we live, right?
Gotcha.
But then to get from 4 to 3, we go through another series of matrix multiplications, and eventually we get to the end, which is what's called the output layer. In this case, happens to be 2 things, but it could be only 1 thing. And that one thing, let's just say, if it was a logistic regression, the one number that comes out. So let's say these 2 boiled down to 1. The one number that came out would be some number between 0 and 1 if you're doing logistic regression. And below 50% would be true, would be false, let's say, and above 50% would be true.
So then
Yeah.
how do you go from, if it's multiplicative, how are you going from 4 back down to 3?
That has to do with the shape of the matrices. Depending on, so the matrices don't have to be square. They can be, they have to be square. No, they don't have to be square. A matrix might be, 40 by 80.
Okay.
And one of these dimensions has to be 40. So this would be 1 by 40. So when the 1 by 40 is multiplied by the 40 by 80, out comes a 1 by 80. And one of your dimensions has to be matching the dimension that's coming in, and one of your dimensions will be the dimension that comes out. And when you get to the end, your last dimension for a logistic, what is a logistic regression? That's the sigmoid function, right? It's either going to be 0 or 1. So you get a single number, which is gonna be between 0 and 1. Typically in logistic regression, it's more than 50%, we say it's true, less than 50%, we say it's false, right? Okay? But there can be other shapes at the end of this thing, okay? And this is also how Wikipedia is used to train large language models. But with many, you know, with trillions, or well, at least certainly billions of circles. And that takes time because even though computers are fast, it takes time to multiply. Okay, so that's what a neural network is. So what we're doing here is we're just we're going to use a sequential model. All a sequential model means is a vector comes in, gets multiplied by a matrix, gets multiplied by another matrix, gets multiplied by another matrix. Out comes either a vector or a single number. And in this case, we're just going to emulate a sigmoid function. And let me check out time here. So they apply the binary cross entropy, which is the loss function for logistic regression. They compute an optimization problem, which is the way the so you get to the end of that matrix series of multiplications, right, Jose? And now you got an answer. And actually, you sent 100,000 examples through, and your accuracy was, 12% the first time, because it was just kind of random. Maybe it's 50%. Maybe that's randomly you're right 50% of the time, right? It calculates where you make mistakes, and it does some calculus to change the values in all those circles by a little bit using calculus. And then it says, okay, do it again. And because of the method of gradient descent, the second time you send the data through, instead of getting 50% accuracy, you get 72% accuracy. And it knows which examples it got wrong, it knows which examples it got right, it passes that information back using calculus, and then you do it again. And you do it as many times as you want to until you're convinced that you're not going to get any better, and if your model is good, then you'll get decent results. And that's what's called training neural network.
Are we doing that with the same set of data, or we're using the 4 sets?
No, we're always using the one set. If we're in the training set, all the X's in the training set get passed through the model. They get compared to the Y values that you're looking to target, right? Your targets in the training set.
Mhm.
And whether they're right or wrong, that information is used to update the numbers in all of these matrices, and then you guess again. And the calculus technique is accurate enough to get you to a good model. Much like, and this is all that really happens even in linear regression, right? How do you get the coefficients for a linear regression, multiple linear regression? You use calculus, right? You say, if you're doing simple linear regression, right, it's y equals a plus bx. How do you get the best a and the best b? Well, it turns out the best b is related to the beta, essentially, but calculus does that, right? You have a function with 2 variables, a and b, and you get your outputs, which is your total error, and you want to minimize your total square error. Calculus will give that answer exactly. Neural networks do the same thing, but dealing with more dimensions. You get things like this, it used to be that you could just write LR. Instead, now there's a learning rate which says how quickly you update your models. Any place where you see a pound sign, that just means that the syntax has changed. So if I go back to the way it was and then I try to run, it says this argument is not recognized. And that's because the syntax has been changed. These are the kind of things that Gemini, of course, is great at. When I ran this the first time, I did not have this changing my numbers from 64-bit numbers to 32, and I got errors. But once I fixed it with Gemini's results, it goes ahead and it runs through this neural network 5 epochs. What an epoch is every one of the examples that I have, I pass it through the network and I make a guess. That's 1 epoch. And then based on the errors that I've seen, I've been up, typically when we're doing, in this case I don't know why it's 13,000. But it tells you what's going on here. My accuracy was 90%, 90.5. So it's getting a little more accurate. It has your loss function, it has your value accuracy, your validation accuracy and your validation loss. And you can watch your model as it trains. And at the point, when it stops, it's done the best it can, at least given, I had 5 chances to look at the data. And, now your model's trained, so let's see what happens here. And again, I had to change my, I think to 38, to 32 bits. And then I finally, one of my predictions, this is your typical logistic regression prediction. If the prediction value is greater than 0.5, I go 1. Because remember, your logistic function looks like this, right? It starts out at negative infinity, never quite gets to 0. It goes through 0, 1, or 0, 1/2, or 0, 1/2, I guess. And then it goes to 1 at positive infinity, right? But it never quite gets there, right? So, and now we get, using these predictions, we get a new F1 score, 0.12. So better than the old F1 score. Not necessarily great, but certainly better. And then he creates this confusion. So confusion matrix is given to you by SGLearn. You know, if we take a look at what this object looks like, let's see what it tells me about it. It just gives, this is what all SGLearn will give you. But there's a lot of data, I think, associated behind the scenes. So plus the confusion matrix, and now our accuracy is up to 96%, not many misclassifications, and now we've gotten 2,200 correct and only 600 wrong. So our fraud detection is a lot better. We've got 30,000 mistakes out of 880, compared to 880,000 transactions waived. So we've obviously done a lot better. Our F1 score is better. Maybe 0.11 might be a decent F1 score in this context. And that was just using logistic regression, as opposed to just with our new heuristic, right? Not our new heuristic. We had some new information. What was our new example was we dropped our fraud heuristic. This was using the hour of the day as one of the new features. And by the way, so this is our new feature, right? So if you look at this data set, is it nighttime or not nighttime? These are just 3 variables we've created. And by the way, one thing that, again, it talks about in pretty much all the books you looked at, most machine learning models can only work with numbers. So false and true are interpreted as 0.
Based on a timestamp, yes.
Well, no, but these are interpreted as 0 as 1, whereas trees don't need numbers. You could say the tree, when you try to figure out how much, you missed it, by the way, last week. We talked about how much baseball players were getting paid. You missed that.
I missed it.
Yeah, it's in the yellow book, the ISL Python book.
Okay.
It's an example, their chapter on trees, which is like chapter 5, I think.
And it's on Cartero?
Yeah.
Okay.
No, it's, the book, right? That we.
No, I'm saying the class, was that one?
Yeah, I did say that. I didn't actually post it yet. I gotta go back and post it.
Okay.
But it's in this book, ISLP.
Indian Super League, hell yeah.
Yeah. I go to the Python one, of course. Actually, I can show you the pictures. This was an example. The data is a little bit on the old side, but the example was very interesting. I was disappointed that I couldn't impress you from baseball. This is the wrong one. Hold on a second. Yeah, so this particular data set. Now this data set's pretty old. It's probably early 90s, but this is just others have already seen. These were the colors represent how much the baseball player was getting paid. The purples, I think, are like 150,000. The high ones are like 700,000. Okay, base salary, right, annual salary. And then this was just 2 categories: the number of hits they got and the number of years of experience they had. And based on basically people with less than 5 years all got kind of paid similar. And they got all the low, the blue and the purple are the low numbers because they're on their first contract, right? But once they get out past 4.5 years, which is the split point, they really start to get paid more.
It's called arbitration.
Right, well, they also get to just be free agents, right?
Yeah.
So, yeah. So, you'll enjoy reading this, chapter
No,
8 of
this
the-
is,
of the book.
speaking my language.
Yeah, yeah. Okay, so they took the, he talks about how, you know, if you have trees, you could have in the baseball thing, where most of the things were numbers, but you could have said, what country does the person come from? And you might speculate that people from Latin America are making more than other countries, because a lot of great baseball players come out of Dominican Republic and Cuba, Venezuela and stuff like that, because they play a lot of baseball. It's sunny, right? They like baseball. And you would be able to leave those as labels. You wouldn't need to convert them into numbers. Although that would still be categorical data. There's only 20 countries, whatever, 30 countries in baseball. So you could just label them with numbers. So you could convert them into numbers. But in general, other models, not trees, really require numerical data. Like machine learning, neural networks won't work without numerical data. I hate when it just does its own thing. All right.
So in this data,
Yeah.
for, the night, I'm
Yeah.
assuming it's looking at the time, 1, 2, 3, and
Yeah.
it considers certain numbers. 1 through 7 is, 1 through 4 is night, and 11 through 12 is, or 10 through 12 is night. I don't
You
know.
get to
Yeah,
define
no,
it
he's
however
got-
you want.
He's got some story. I don't have it handy right here, but,
But it's in the book, or whatever. You got the code here, but it
Yeah.
tells the story. In
no,
the
no,
book.
it should be, we should be able to see it here too. Okay, so hour, right, so they use hour, and then is night, is the hour is greater than or equal to 2, less than or equal to 6. So between 2 and 6.
Got it. Wait, so 10 o'clock is not nighttime?
No, we're talking middle of the night now, 2 a.m. to 6 a.m.
Got it.
Okay. So maybe that's why your baseball bat wasn't flat, because it was maybe only 157, and they said this guy is okay. So interestingly enough, by this remaining set of data, 35% of the nighttime transactions were frauds. So all they've done is they've only created one additional feature, and they get, what was our result? So when we did the logistic regression, we got our score up to 12.12 for the F1 score, okay, so we're doing better. Then he goes ahead and says, I'm gonna make a neural network out of this. And that's what this is saying. This sequential in Keras just means I'm gonna make a series of matrix multiplications. The input layer is shape 9, that means there's 9 features. It's a dense matrix of size 16, that means the matrix is gonna be 9 by 16. And then the first output will be 16. He applies an activation function, which is the hyperbolic tangent. Looks the same as the sigmoid, except it goes between -1 and 1 instead of between 0 and 1. And what that does is that takes all of the numbers and applies that hyperbolic tangent function. And then he does one more, so he only had one dense layer in here, that's one of these big multiplications. And then he adds a layer of output, which is only one, he applies a sigmoid activation to that. The reason why you need these activations is a fact that you learn in linear algebra class, is that if you take a matrix and then multiply the result by another matrix, and then by another matrix, everything is linear. Matrix multiplication is linear, whereas, which essentially means that multiplying by 100 matrices in a row is just like multiplying by one big matrix. But if you put a nonlinearity, a sigmoid function, or a hyperbolic tangent in between, you now break the linearity and you get nonlinear features. That's kind of the goal of trees, to be nonlinear, or for neural networks. And then he goes ahead and runs the model, it takes a little bit longer, and let's see what the results turn out to be. So this is a 1-layer deep neural network, and we end up with F1 score is only 0.05, so not so great yet. Worse than we did with logistic regression. That kind of surprised me. I thought it would have done a little better. All right, so anyways, okay, that's where we get with neural networks. Then he goes into tree-based methods. So we talked about trees last week. The basic idea is a decision tree is you just, is it a man or a woman? Is it a child or an adult? Is a person rich or poor? And predict, did they survive the crash of the Titanic based on that? Or there's maybe 13 features. In the baseball case, is it a young player or a veteran? How many hits did they have? More than 150 or fewer? How many RBIs come in? You got a lot of, the second version of the model has a lot more statistics in there. And we get a decision tree. So this one, we actually get a picture. Picture's not really that easy to read. Let's just see what it says. At the top layer, maybe if I bring the book up, you might see it better. Maybe it doesn't pop up just right here. Okay, so I'm just gonna skip that for now. I can't even really read these things, but let's just see. Anyway, it's this particular tree, it went 1, 2, 3 levels deep. So that was what the settings were. And these libraries have these features, so you can see when he creates the tree, he says, import a decision tree classifier, fit it, and I guess okay. So the decision tree classifier decides, sklearn decides how many trees to use and when to stop splitting. It makes those decisions. This graphing function, it just says, hey, only make the max depth 3. And if I make the max depth 2, we get something that's a little bit more readable. It doesn't like that. Oh, that thing, let's see. List index out of range. Okay, so I screwed something up there. And if I go back to 3, maybe it will work. Maybe it's just broken earlier in the process. Yeah, I think that's what's happening. Okay, so let's not worry about that. The next model he applies, we learned about last week, the random forest classifier. Random forest builds many small trees, only 2 or 3 nodes deep, and uses a random subset of the features. So even though we've got 10 features, I think, in this data set, each tree will only be allowed to look at, say, 4 of them and find the best choice. And the idea is that you might have one feature that's really dominant, and if you build a lot of trees, they'll all pick that dominant feature every time. But by randomizing it, you exclude that feature, so you get more information out of the data set. And here we end up with an F1 score of 87.5, which is obviously outstanding in comparison. So the random forest is a big winner here, and we get our, our accuracy jumps to 99.93. And you can see we've got 80% of the frauds are picked up, almost no rejections. Which if you're the bank, we talked about this in the past as well. If you're the bank, you might want to be even a little more aggressive at denying claims to get a few more of these frauds and risk having a few more of these. Because most of the time you get that little message on your phone, is this you? And you say, yeah, it's me, and things go through. It's not that big a hassle nowadays. It used to be a phone call. Citibank, are you there? You have your credit card. It's in your possession. Can you verify the last 5 transactions? Did you spend $17.92 at Stop and Shop in Raymond, New Jersey? Yes. Okay, did you, et cetera. But now it's all much faster. Of course, there'd be people around the work, I suppose. That's the downside. Finally, he brings in the XG Boost, which is thought to be the Cadillac, as it were, of models, to use a metaphor from the 1970s, let's say. Turns out it doesn't quite do as well as the random forest, but more often than not, it will do better than random forest, because it's pretty much built the same way as the random forest, with just a more clever way of building new trees. he mentions in the book, a thing to do would be the random forest model and an XGBoost model, and maybe some other model like a support vector machine model, and then let them all vote every time. So you get that's called ensembling, when you have many models that make a vote. And you know, in terms of actual accuracy, it's pretty close. And then finally, it's into this concept of entity embeddings, which I think it's not a good time for us to talk about it, because I don't understand it that well myself, but it's worth reading. And he does end up with he doesn't even give a result, so I don't even know how good it worked out. Okay, so that's what we got for this semester. We're done. Been pleasant. I highly recommend you continue your study. How many people are graduating? Last class? Congratulations.
I'm still 20 credits out.
Okay, that's good. I'll be here next semester. We'll use that Stefan Jansen book in the fall. I have an asynchronous online class on algorithmic trading, which tends to be a pretty good class.
So, Cliff mentioned a summer class. That's like the intro to this class.
No, that's not
It's
quite.
derivatives.
It's introduction to options, essentially. There's a
Like trading options?
There's a 3-part course that the Financial Risk Management FERM program takes. There's actually 2 different 3-part sequences. I teach the 3rd part of the risk management sequence. And we talk about call options, put options, exotic options, skew, volatility.
Lots of Black-Scholes in that class?
Black-Scholes is in there, yeah. They may have seen that this semester. They used to see it in the spring. I don't know if they saw it this past spring, but
Michelle did some of it.
he did something.
Yeah. He does the first order ones for the most part.
Yeah, I'm gonna figure out I'm getting the syllabus so I can tweak this semester's syllabus. Yeah, we talk about.
You need his syllabus? I can probably send it to you.
Oh, yeah, send it to me.
Well, you can use are you using Hull's book again? You're gonna go to that Bodie book is not that good from what I can see of it.
I'm not gonna, I'm gonna go with what I know. The whole book has been around for 30 years. He died this year. But it's in 12 editions, and it earns there's other things in finance now that maybe are more interesting, but to learn about options and swaps and a few other concepts, it's credit derivative.
Bodie goes into nothing like that.
Yeah, no, this has a lot of good stuff in it. I mean, Hull will teach you, risk management, which is delta, gamma, vega, rho, interest rate risk, and that's what we'll talk about. And that's good. I'll be doing 6 weeks in person, 6 weeks online, every other week, more or less. Will be in person. Starting on May 11th, it's Monday nights.
We didn't do Monday last year, did we?
That's rough.
No, but I've moved my preferred day to Mondays. Okay,
This was awesome.
thank you. I appreciate your attention. I wish I had maybe just settled on one book earlier. I think it would have gone a little smoother, but, live and learn.
We're even if I'm not in the class, I know Professor McDonald said it, but I'm open to email you if I.
Anytime, reach out to me on LinkedIn. My UConn email would be good for the foreseeable future. I don't think they ever cut me off. I've taught, this is like 11 years now I've been here. I've taught almost every semester of the past 11 years. Certainly the past 5 years, I don't think I've missed one. It's weird, every semester I get a new contract. For like a couple of weeks, I can't access payroll because I'm like an employee, but my email never goes away, which is good.
Well, now
But
that-
I gotta fill out this whole, when you do a new job, like, are you a citizen?
You gotta
Are
fill
you
out a
married?
W-4 every time?
I gotta do, I only have to
Thank
do,
God.
every 3 years I gotta do one of those. That was a pain in the neck last year. But I do have to do, what's my ethnicity, am I a military veteran, do I have a handicap? And every semester it's, And sometimes if I'm teaching one here and one that's run by the Hartford Business School, even sometimes the online classes are actually Hartford listed, I gotta do 2 of them in a row. And
You would think they'd be a little more sophisticated by now.
I comply, you know, I'm a good robot. I get the task, I do it.
So do you, in your day job, you actually trade natural gas?
Yes.
Hold on. So, what type of volatility did you see now that we, once? I mean, I'm assuming that there was a spike in demand for natural gas futures, the shit that was going on.
Well,
That continues.
US natural gas prices did not respond that much to the war in Iran because there's only one way to get natural gas out of the US into Europe or Asia, which is by liquefying. So liquefying, you take natural gas, which of course is gas, you chill it to like negative 260 degrees Celsius, I think, and it becomes a liquid
condenses.
and reduces its volume by a factor of 600.
Okay.
So that gets put on those ships. I think most of the ones you see with the balls.
Yeah.
I think those are all LNG ships, liquefied natural gas ships. Then they get shipped to somewhere, wherever they're gonna go, either Asia or Europe typically. And then they have, on the other end, have a gasification process where they warm it up and it becomes a gas again, then you can go through pipelines. But there's only so much capacity for liquefied natural gas in the US, and it's currently all being used. Building new plants takes like 4 years, and there are more plants being built. You know, when this shale revolution happened, which was like, say, started in 2004 and really started to take hold by 2010. In 2008, when I was working at AIG, ground zero for the financial crisis, literally ground zero my building, and but we were looking at a deal for a regasification plant down on Louisiana coastline called Cheniere is the name of the company, which means we were getting ready. They wanted to import liquefied natural gas into the U.S., probably from like Trinidad and Tobago, but from Oman or Qatar, right? And we were going to convert that into gas here so we could use it in the U.S. But the shale revolution took off, which meant we had more gas than we knew what to do with, and they changed that plant into a liquefaction plant for outgoing gas. That was one of the first ones built. They always had regas up in New England because there's not enough pipelines to deal with the New England winter. So that they do import, it's one of the few places in the country where they import gas for use locally.
From
But
other
there are
countries
about-
or from the U.S. like it's
It comes from Russia,
It probably
actually.
comes from, Russia would make sense.
New York won't let us build pipelines across New York.
Right.
Trump finally said that to New York, and says he's building them anyway. But
But, it comes from overseas typically, I think, because we didn't have any, we were net importers of gas, or approximately zero, say 2008, and then that changed with the shale revolution. We're now the world's largest producer of natural gas and the world's largest producer of oil. And we take some imports in from Canada, we ship some down from Mexico, but we can only send so much out because we only have so many of these liquefaction plants. I think there's about 10 of them now, mostly along the Gulf of Mexico coast, but also in Baja California. There's at least one that was built by Sempra, and there's a second one getting ready to go online. And they're building a big one up in British Columbia to send Canadian gas over to Europe. The biggest importers are the JKM market, which is Japan, Korea, I don't know, Malaysia, I guess, must be the M. And so they import a lot of natural gas over there. But Europe also imports.
Have they done a study or has anyone taken a look at what the market or appetite is here for natural gas, so what type of capacity there is?
Well, they think about it all the time, of course, right?
That's what I mean. So I'm assuming.
So
that
they're
there's
gonna
a
build more,
huge-
they're gonna build more plants, more liquefaction plants, but it takes years. And then when you build the plant, you also, all the pizza, we've got like almost a whole pizza here. Why don't you, box them up if you're so inclined, don't be afraid to take the whole box, because not everybody, there's also drinks, take drinks with you, if any of you want bottles of water. Anything you don't take, I'm gonna have to carry, which is. So then, given this, yeah, so we're building them, you know, but it takes a lot of time, and,
But why does it take so long?
because it's a complicated engineering.
Look at the size of the
process.
plants.
It's a massive,
You know, permits are half the problem.
you gotta get permits, you know, to make sure you don't, blow stuff through the wetlands, or, you know. But it's a big, it's a fairly large engineering project. It probably takes 4 or 5 years to pull. After you've got the details in place.
Interesting.
Did you send them already? Let me see. Especially with this. Come on, 2 more slices. I think we're gonna be ready. Nobody wants drinks?
I was gonna say this,
Diet Cokes, Cokes? Nobody wants Cokes?
this thing looks a little too small.
Seltzers of all kinds? Drink?
Definitely will take
Yeah, that's good, that's good. I have a bag too, so, you know, take, you wanna take more? Sample more.
I've got a million seltzers.